Hello everyone, in this video I will talk about unimolecular nucleophilic substitution, abbreviated as SN1. This molecule is an organic halide, or an alkyl halide if you like. It will be the substrate of our reaction. Bromine is a halogen. It has a high electronegativity compared to carbon. By attracting the electrons from the covalent bond, bromine may eventually lead it to break. However, the bond is readily formed again. That means the system is in a dynamic chemical equilibrium. First of all, let's understand how it's favorable. After breaking the bond, bromine stays with the two electrons, including the electron from the tertiary carbon, which becomes positively charged. The ion formed is called the tertiary carbocation. Now it's important. The more the positive charge can be neutralized, the more thermodynamically favorable for the carbocation to exist. The tertiary carbon is attached to three methyl groups, which are alkyl groups. Alkyl groups have an interesting property. They tend to donate electron density, favoring neutralization of the positive charge, and so the stability of the carbocation. Okay, understood that, let's move on. Although relatively stable, it's not neutral, it's still a cation. And that is attractive for a new participant of our reaction, the nucleophile, represented here by water. Nucleophile is a chemical species that possesses at least one free electron pair, and so is attracted by molecules or groups that are deficient in electron density. As the substrate is a cation, there is no need for a strong nucleophile. The water molecule will readily carry out its nucleophilic attack on it, completely neutralizing the carbon atom. But by using two electrons to form the new covalent bond, now oxygen becomes positively charged. As oxygen is also a very electronegative element, it will attract electrons from one of its bonds with hydrogen. The hydrogen, in turn, is released to the medium and captured by another water molecule, originating the hydronium cation. At the end, we have a bromide anion, a hydronium cation, and an alcohol, the main product of the reaction. But why SN1? Why that name? There are two initial reactants. In fact, this name is because only one of those molecules is responsible for the rate-determining step of the reaction. And such step is the formation of the carbocation, which is called a slow step. Its rate depends on how stable the carbocation is. As in this case, the carbocation is linked to three alkyl groups, its formation is more favorable than it would be for a secondary carbocation, for example, as would have only two alkyl groups to donate electron density. After the slow step, the attack by the nucleophile occurs quickly, being called the fast step, not interfering significantly to the rate of the reaction as a whole.